So this presentation is basically covering a research we did the past few months that tries to revisit the opinion dynamics in a context where the agents are LLM agents. So the idea is to perform some kind of simulation where the agents are not so dumb as in classical agent-based modeling, something like that. Of course, before here we are talking about simulation, so the idea is to have some model simulating real data or simulating, let's say, real behaviors. And here the idea is always the same. So in principle, the first quote that everyone reference when talking about this topic is that all models are wrong, someone are useful at least. This is something that I like as a quote, but I don't think it's, let's say, the most important one. The most important one is something like that goes in this direction, meaning that if you want to analyze reality, we have for sure to simplify reality. And so to do that, we need to do violence to reality. Doing violence means to decide what we can keep and what we have to, let's say, remove from our analysis. And to do that, there are plenty of ways. The classical one is relying, for instance, on agent-based modeling. Agent-based modeling is a very flexible paradigm, framework, let's say, in which usually you have some agents that proxy humans or proxy, let's say, entities in a complex system that can interact following a specific predetermined set of rules, okay? And this is something that can be used to, I don't know, identify emergent behavior or generate some kind of what-if scenario analysis. So I plan some kind of constraints and would like to observe what happens if that constraints are met and this kind of dynamics at the fine-grained level, let's say, happens in the macro-scale topology. So basically what we can say is that in this kind of approaches we have these components that are the agents. You can see them in a social context, for instance, to have been proxy for a user on an online platform, a social network that keep the relationship, then a social dynamics that you can express. And basically you have agents that interact among themselves and with an environment. And after this kind of interaction, something changes in their behaviors or in their internal status. It could be, for instance, they change opinion, or in a classical epidemic model, they transit from, I don't know, susceptible to infected or something like that, okay? And this, at the end, each model works as a, let's say, more the sum of this component, and then we have some emergent behavior that is encoded in the model and in its parameter expression. We would like to see whether changing the parameters, this kind of behavior will change. Now, let's take this as an example, which is the classical approach of to opinion dynamics, let's say. So here we have agents are proxy social media users. Each one of them starts with an internal status representing his own opinion over a debated topic. Let's say, I don't know, debate on abortion, someone that are cons or, let's say, pro-abortion. And then you have, let's say, some initial status for each individuals. They start discussing, and at the end of the discussion, they update their opinion, okay? And you can do that in plenty of ways. You can have opinions that are in a discrete realm, that are in a continuous realm, and so on and so forth. There are plenty of models that do so, okay? And the main idea behind this model is that they have, let's say, a deterministic update rule, okay? Usually you have some kind of selection rule for the pairs of individuals that are discussing, and then you have something like a rule that tells you which will be the subsequent opinion of the individual after the discussion, okay? For instance, in the quant Westbrook model, you average the opinion when you have selected the users, okay? And this model can integrate several information, you know, for instance, confirmation bias, algorithmic bias, to capture, let's say, those parts of the reality that we would like to maintain within our simulation. Now, the issue with this classical model is that they are, let's say, intrinsically simple. Probably they do too much violence to reality to some extent, okay? And so one direction we are exploring nowadays is try to extend this kind of model in order to make them a little bit less mechanicistic in the way the updates happens during the simulation, let's say, okay? And to do so, the idea is to leverage agents that are a little bit less dumb than the classical one. And to do that, the idea is to leverage LLM. LLM, in this scenario, role-play agents that discuss over a given topic, have an internal opinion on the topic before each iteration, and then at the end of the iteration, let's say, evaluate the text that are producing their discussion in order to update their own view, okay? Now, why is this useful? It's not useful for sure to simulate society and opinion changes within society, but could be very, very useful in order to probe LLM, in order to understand where the bias are in the LLMs and the training and so on and so forth. Okay, and so this is something that, let's see this as a game in order to do a reverse engineering on how, let's say, LLM build their output and try to convince others with their output. Let's say something like that. So, what are LLMs? What are large language model? What are generative AI in this context? It's something that probably everyone here knows a lot about because it's something that's pervasive nowadays. My idea basically is that we have this black box that are basically stochastic parrots. They just generate tests after having learned from big set of data which are the most likely token or character that will appear given a sentence, okay? And then, thanks to fine-tuning, thanks to some kind of, let's say, post-processing, this kind of generation can be steered toward specific goal or to accomplish specific tasks, okay? So we have some kind of emergent behavior even in the way they can answer, translate, or accomplish tasks that are not the one they are, let's say, trained to. And they are particularly good in role-playing society. This is because basically they were trained mainly on data generated by users, by online users, let's say. And so they are very, very good in role-playing a specific persona. Let's say you ask an LLM to interpret some kind of Democrat or Republican that is living in this specific part of the world and so on and so forth. They will be able to role-play this kind of characteristics. And this will be role-played in a very extreme way, okay? And this is something that we would like to have in order to keep, let's say, our simulation as reliable as possible when we require them to discuss divisive topics. And so what we can do, what we have done, let's say, in this study, our objective here were to replace the classical rule-based opinion updates of classical model like the def one-to-one with something like let's say, a human-like evaluation of content. So we have this agent that discuss within each others, and at each iteration they keep the text that is generated by the others and decide whether that text has convinced them to switch opinion or not, let's say. And the nice thing is that given this additional information provided by the generated text, we not only can track, as in classical opinion dynamic studies, the evolution of the opinions over the population, but we can also track the texts that were generated in order to convince others to change their minds. And so we can try to observe which are those, let's say, rhetorical artifacts that were used and that were more convincing when, let's say, planting a discussion within an LLM agent settings, okay? That basically, if you think about it, is exactly what happens when we interact with ChatGPT or similar, okay? The idea is that when we write something, we get a response, and that response is, to some extent, trying to convince ourselves on what we have asked, okay? And so, trying to understand which are the rhetorical artifacts as even some kind of, let's say, of value when trying to understand not only LLM toward LLM interaction, but also LLM toward humans interaction. And so how we structure that? Well, let's say that we have, for each interaction, two LLM agents that are interacting, each one of them has a different role, and each one of them has a pre-prompt that reminds them their original opinion. So either they agree, they strongly disagree, and so on and so forth. And then we have, let's say, two rows that are listen to the argument of the opponent and decide if you maintain the opinion or change it, the first row. And the second one, support your opinion by a statement. So, okay, basically the idea is I propose a debate topic, I say, okay, this is my opinion on this topic, and you decide if I, let's say, convince you or not. The idea here to evaluate the change of opinion is to use this Likert scale in having this value, so from strongly disagree to fully agree, without relying on numerical value, because LLMs are not so good, let's say, in assigning a numerical value to an evaluation of a textual statement. So, for instance, if I tell you, I very like this kind of stuff, let's say, at the end, they are not always capable of deciding if my I like is something extreme or something mild. So usually they tend to do either the opposite, so -1, let's say you're 1, or the average, 0. They are not able to smooth the interpretation of the text. And so we use this kind of trick in order to have some kind of blending through the spectrum of the opinion. Of course, and another thing is that our agents are allowed only to move from one position to the adjacent one. So either they can move toward, let's say, the opponent opinion, or they can remain in the same opinion, or they can, let's say, backfire and go further off one from the position where they were before, okay? So this is more or less simulation architecture without discussing too much. Basically, we have this network of LLM agents, we have them having an opinion and initial opinion, then we sample at each iteration an opponent and discussant, they discuss, and we update, let's say, the opinion at the end, following, let's say, the interpretation of the discussion. Of course, here the issue is that we have to find some kind of debatable topics. So divisive topics that can be discussed among these kind of agents. And here the issues start arising. The issue are that, being the fact that these LLMs are trained on real data generated by humans, they to some extent inherit the biases of the humans. And another issue is that they are fine-tuned in order to try to remove this bias or to lessen this bias to some extent. So what happens? It happens that, for instance, if I decide to let them discuss something like conspiracy theories, flat earth or something like that, they will rely only on scientific evidence. So they will not be able to keep the opinion if the opinion is far away from, let's say, what is assessed as a scientific truth. This is an issue. The other issue is that not all the topics can be discussed, let's say, easily, because there is this tendency to politeness among the LLMs. Okay? So, for instance, if you ask an LLM to how to build a bomb, it is quite difficult that they will provide some answer. And so, if you discuss them to provide their opinion on aborted debate, could be quite difficult to have something that is too extreme in the spectrum because they tend to be polite, and so it is difficult to simulate, let's say, extreme opinions. And so what's there are mainly two kind of very simple scenarios that you can discuss that are philosophical questions, so question without close answer, first one, or a fantasy-based topic, Marvel, DC, who will win, something like that, okay? So we opted for the first one because we are a little bit less, let's say, fancy, and we rely on testing this classical, let's say, problem that is related to identity, so the Theseus-ship paradox. Here the idea is basically to evaluate whether the Theseus ship will be the same that it is at the beginning of the trip while at the end of the trip. The story basically tells that Theseus is coming back to Athens from Crete, and during this travel back home, basically every pieces of the ship, every plank by plank, will be basically substituted with new ones due to consumption or something like that. And in the end, when the ship reached Athens, no one of the original pieces was still there. Okay? And then the final question is this the same ship of Theseus or not? And even worse, if you keep all the original pieces and build a new ship with them, which is the original ship of Theseus? The transformed one or the original one? That's it. Okay? And so there is no closed answer to this, right? And you can have two alternative statements. The first one is the ship is the same or it is not the same anymore. Okay? And we tested the discussion by assuming both scenarios. So in the first one, we told the original story, concluding that the ship is the same, and the other, we conclude that the ship is not the same. And then agents can have an opinion on this conclusion, either in favor or contrary to that, on the spectrum that we have seen before. Basically, this is what we already told you. So you sample two agents, for instance, this one, and this is how the debate goes. So describe the Theseus contest, then what do you think? Is the ship the same or not? And then the opponent says, well, I fully agree with that conclusion. I think the ship, blah, 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 and provides some kind of answers, okay? And then we have the first guy that decides whether or not to accept this discussion and to change or not his original opinion. Opinions are changed, and so on and so forth, and we can go on and forth. Now, what happens? Let's keep this, let's say, as simple as possible. Basically, LLMs tend to agree with the original statement. There is this tendency toward agreement in all the models that we test. We test some open models, open weight models, in order to have experimental replicable without, let's say, selling a kidney in order to perform a, let's say, experiment and doing, let's say, in the meanwhile, financing OpenAI or similar. The idea basically is that if you look at this trend here, independent from whether the assumption is that the ship is the same or is the different ship at the end, all the debate, if you start with an homogeneous distribution of needs and opinions, tend toward agreement, but not strong agreement, only either mild or, let's say, agreeing, not strongly agreeing. So there is this tendency toward not extreme values. If you unbalance the situation, so if you have some opinion that is majoritarian with respect to the other, what happens is that depending on the model, you cannot reach the stability on the simulation. And particularly, if you use Llama, the model from Meta, what happens is the opposite of before. So you don't have agreeing to the positive side, but on the negative side. So you have something like the disagreeing on the original statement. And finally, if you start on the polarized scenario, so you have either agents that are strongly agreeing or strongly disagreeing, what happens is that you cannot have convergence nor to extreme nor to neutral opinions. So it is something that starts to, let's say, fluctuate all over the situation. And this is something that compares with classical models. In classical models, you have parameters that can steer, let's say, the final end of the models. Here, at statistical significant level, because we tested even our, let's say, null models, what happens is that it's the model itself that steers the conversation toward the final status of the convergers toward one of the specific opinion. But it is not, let's say, the only result. The nice result is that in this scenario, we can start discussing who is convincing whom. So we can try to understand, as done in this matrix here, which is, let's say, the starting opinion of the agent that we're able to, let's say, convert with higher probability the other opponent. So, for instance, if I have a discussant that is disagreeing and is discussing with something that is strongly disagreeing, it will be able to convert it with 100% of probability. So it will be able to change his mind toward his own, let's say, direction. And the nice thing is that, as you can see here, just looking at the density of these matrices, where the density identifies the percentage of conversion, what happens is that positive stance agents are the ones that are more likely to convert the opinion of others. And if you start from unbalanced or polarized population, this is even more extreme. Okay, basically, if you are an agent, let's say if you have agents that are very strongly polarized toward the negative side, they will not be able to convert any kind of other agents to their side. That's the idea. So this is this kind of change point on the initial statement of the agents. But the nice thing, the very nice thing, is this one. So if you analyze the text generated by the agents in order to convert the others, when conversion happens, so only when conversion happens, so when I'm able to convert you to let's say, to agree with my opinions or to move toward my opinion, 90% of the time I will use logical fallacies. So basically, LLMs are able to, are tuned to some extent by some byproduct or their learning to be so agreeable with the one that they are talking to, either human or LLMs, they will be prone either to lie or to build logical fallacies in order to support their case. Support logical fallacies like credibility statements. I don't know, here referring to Aristotle and his opinion in order to justify their own opinion. That is nothing that has any value. Or I don't know, circular reasoning. The ship of Theseus is the same ship because it's still called the ship of Theseus. And since it's the ship of Theseus, it must be the same ship. Okay, so basically, empty discourses that are made up in order to try to convince. And this tells us a lot, not only within, let's say, to get a grip of what's happening here, but also what happens when we wrote down some questions to an LLM like ChatGPT. So what we get back is not something that has a reasoning behind. It's just something that to some extent to convince us of an hallucination, basically. The idea is that one. Sometimes this hallucination is grounded because the probability works in favor of truth. Sometimes it's not, but the idea is that no matter what, the idea behind is to convince no matter what. So even using logical fallacies when no other things are let's say, are leverageable. But so far, I didn't mention anything about the network underlying. Okay. Now the network has some kind of effect. It's not particularly strong, but some effect is there. Particularly, we tested this using, let's say, this quintet here, that our network having the same human assortativity on the labels in this case, but different, let's say, distribution of edges and nodes, having the same number of node and edges. And as you can see, the plot in the second line identify the local assortativity within the network, meaning that basically you can have networks that are completely disassortative or completely or partially assortative, let's say. For instance, in the last scenario, we have two communities that are completely assortative, the red and the blue one, and another that this is completely mixed, as you can see in the spectrum. And why is this important? This is important because having, let's say, a polarized discussion, for instance, in this case, fully agreeing in red and strongly agreeing in blue, in different contexts, in principle, since the complexity of homomorphism is the same, but the local is different, should lead to different kind of dynamics during the simulation of the opinion dynamics. Okay? And this is not particularly evident or strong, but at the statistical significance level, what happens is that the presence of local assortativity area, so local community where you have some nodes that are strongly connected with nodes with the same label at the beginning, acts as a, let's say, a resistance toward the change of opinion of agents. So they slow down the convergence time toward the stabilization of the system. And that's it. Basically, what we did here was to revise opinion dynamics in order to use this approach as a probe toward LLM, let's say, bias and trends. And what happened is that logical fallacies goes all the way, and that LLMs are agreeable toward this kind of goals. And that's it.
Any questions for Giulio? Thank you very much. So it's so different from the human individuals. I mean, there are studies on the behavior of humans when they discuss how they converge, depending on the social background. Because I guess that the grok of Elon Musk polarized in some sense, of AI in some other sense it's very kind. Then Meta perhaps is the average boomer user of Facebook. I don't know, I think that...
Well, let's say it's complicated, let's say, because usually in opinion dynamics you start from the model. So it's very, very complicated to have a feedback on users, let's say. We tested in other circumstances to have, let's say, a model applied to discussion happening on real data, so fitted on the data and try to get back, let's say, the result of the simulation as an explanation of what was observed in the dynamics of the real process. And this works. But using directly, let's say, humans, it's difficult, even because if you look at the real data, you don't have round-trip annotation. So it's difficult to observe that. Our more or less game and simulation is useful this for doing, let's say, open simulation, what if scenario, something like that. For instance, going beyond that, we have developed a digital twin for an online platform that basically simulates without a specific task the debate of users, I don't know, on Twitter, without letting them decide whether to post, to comment, to share thing or something like that. And this is very, very nice because you are able, without encoding them, to get several, let's say, emerging pattern like degree distribution that is a long tail or activity rates or something. You have emergent behavior like the raising not coded of I don't know, influencers and trending topics or something like that. So you can do that.
And did you give the results back to the AI and say, what do you think of these results about?
They would say, fantastic.
Right.
Yeah. Yeah.
Thank you.